Thank you for that great introduction, and to the Middlesex Conservation District for bringing me here to the Fowler Library today. I'm really overwhelmed to see a full room of people who want to learn about OARS, people who support OARS. I'm from Wayland, and it's such a fun blast from the past to see some Wayland faces here. So I just want to start off by having people who currently volunteer for OARS or who have volunteered for OARS in the past. Could you raise your hand? Great. So if you have questions about volunteering at OARS, you can ask Alyssa or ask one of the people who raised their hands today. And I'm just excited to be here. So thank you for having me. I'm Abby McCarthy, and I'm the Water Quality Program Manager at OARS Three Rivers, which is the organization for the Watershed organization for the Assabet, Sudbury, and Concord Rivers. And if you just happen to be in the library today and you're stopping by and you have no idea what this is, even better. I will explain it to you in detail. So during this presentation, I'm going to discuss 5 main themes. What is a watershed? Where is this SWOSCO watershed that I'm talking about, where we are located? I'm going to talk about water pollution in our watershed. Who is OARS Three Rivers, this organization that I work for, and the history of OARS in mitigating pollution in the watershed. I'm going to talk about the ongoing water quality monitoring program at OARS and the extensive data sets that we collect in this program. And I will talk about how you can get involved in a variety of meaningful and fun opportunities to help the watershed. I also want to give a shout out to Callie. Callie, can you give a wave at our table in the back? This is our TerraCore Community Engagement Coordinator. And after this presentation, I encourage you to stop by the station to grab one of our river recreation maps. What is a watershed? It's an area of land where all the water flows and drains into a common water body, such as a river, a lake, or eventually into the ocean. Water from rain and snow can flow across the land, or it can seep into the ground as it infiltrates to join the groundwater, shown here. And as water flows from the smaller streams into the larger streams, on its way, it can pick up pollutants from some of the sources shown here, such as picking up pesticides or fertilizer from agriculture, such as picking up materials from urban runoff in cities or towns, perhaps picking up salt from roads, as is common around here. And we all live in a watershed, whether we like it or not, we do. It's just a fact. And here are the watersheds in Massachusetts. All the water that comes down as precipitation runs into some body of water eventually. We here are part of the larger Merrimack watershed, and water flows from the White Mountains region of northern New Hampshire into the Merrimack River. We are located in the Concord sub-watershed, also called the SWOSCO, circled here. And here we are in the Fowler Library in the Merrimack watershed. This Concord watershed includes the Sudbury, Assabet, and Concord Rivers. So the water is flowing from south to north. I know it's kind of confusing that way. It got me too. It's flowing from south to north into the Merrimack River, from the Merrimack River into the Atlantic Ocean, as shown here. So we have 3 sub-watersheds in a sub-watershed. Don't think about it too much. And here are labeled the Concord, Assabet, and Sudbury Rivers. So OARS is working to improve the health of these 3 rivers, and our sub-watershed, this SWOSCO, because it's the Sudbury, Assabet, and Concord, so we call it SWOSCO, sub-watershed, includes 399 square miles of land. There's 36 municipalities, which is 33 towns and 3 cities, And there's 84 miles of river, 29 of which are designated, protected as wild and scenic. And here in the watershed, there's 8 wastewater treatment plants, as well as 161 dams. If you have questions about dam projects and dam removal, that is a whole nother topic that OARS does a lot of work on. And I will give you the contact information of my awesome coworker, Heather, who is our ecological restoration specialist, who does a lot of work with dam removals. These rivers are beautiful, beloved recreation areas enjoyed by many people. And they are the wildlife home for a variety of creatures, such as snapping turtles, fish like the brook trout, the crayfish, birds like blue herons, animals like beavers, animals like river otters and muskrats, turtles, and all of these animals, as well as us humans, live in a watershed with a variety of pollution sources. There is intense development pressure, which increases the impervious surface of the land, meaning that water is prevented or delayed from infiltrating. Salt from roads washes into our rivers and increases the chloride content and the specific conductivity. And in this rapidly suburbanizing area, new buildings are built, fertilizer is added to lawns, and many materials and nutrients wash into our rivers. We also live in an area with an industrial history that has created old mills and outdated infrastructure that still continues to impact the water quality in our rivers. There are dams left behind, mills left behind, and contaminated sediments as a result. Some spots are not so beautiful and still contain trash. Eutrophication, or excessive plant growth, does continue to threaten some of the rivers. This has caused a water quality crisis, and this is why OARS was born. OARS was born as OAR, founded in 1986 as Organization for the Assabet River. The acronym made a lot more sense back in those days. And they advocated for stricter regulations for wastewater treatment plants so that wastewater treatment plants could not keep putting untreated wastewater directly into the rivers. They won lawsuits. They collected data sets with hands-on volunteer community work coming together, and they directly cleaned trash out of the rivers. OAR changed its name to OARS in 2011 when they added the Sudbury and Concord Rivers. This is what our rivers used to look like in the 70s and 80s when the Assabet River was called the cesspool of Massachusetts. And plant mass used to grow so widely and thickly, there was a strong smell of pollution on the rivers, and excessive phosphorus and nitrogen entered water from wastewater discharged from 5 wastewater treatment plants. Point sources of pollution were very high, meaning that it was measurable that pollution was coming directly from wastewater treatment plants into the river, releasing untreated sewage. And this meant that more than 82% of the phosphorus entering rivers during this time was from the wastewater treatment plants. It was estimated 82 to 97% of phosphorus was from wastewater treatment plants during this time, as well as between 91 to 99% of the nitrate entering rivers and increasing plant growth was coming from wastewater treatment plants. And these are the reasons why the Organization for the Assabet River, OAR, was founded. People wanted to come together to address these issues and to transform the watershed to help make it look like what it looks like today. This photo was taken during a milestone moment when the Concord River became swimmable again. And that's proof of what can happen when communities and organizations come together. OARS accomplishes this mission through science, action, and community. Through our main programs, river science, outreach, policy and advocacy, ecological restoration, and climate resiliency, as well as education, like this presentation, and increased recreation opportunities. I will talk about this more. Education and outreach are essential to OARS' mission because connecting people to these rivers builds a legacy of people who want to act as stewards. And OARS has educated more than 600 children with our 2025 education programs, which include water-wise workshops led by our TerraCore participant, Kelly, that are intended to get more people involved in caring about protecting rivers. We use science to advocate for policies by writing letters and also negotiating settlements under the Clean Water Act in order to create policy change. We also have the Ecological Restoration and Climate Resiliency Program that works to help promote treating stormwater runoff before it enters the Swasco, as well as dam removals, rain gardens, water chestnut pulls, and invasive aquatic species workshop, a huge variety of programs run by my coworker, Heather. And finally, the water quality monitoring program, which is made up of myself and a fantastic team of volunteers. Some of our volunteers have been working with OARS for more than 20 years, and they are a seriously awesome crew. We also take new volunteers every year. So the main goals of OARS monitoring program are to understand long-term conditions of the rivers and their tributaries, to provide sound scientific information that can be used to support regulatory decisions that impact the rivers, and to promote stewardship of the rivers through volunteer participation directly in these projects. This is some of the projects ongoing: water quality monitoring, macroinvertebrate monitoring, that I will get into more. These volunteers go out to the rivers and sample the water on a regular basis, starting in the 1980s. Starting in the 1990s, it was 1994 that our data sets first started being put into an annual report every year. But the data collection goes back a couple years further. And basically, my volunteer team goes out in March, May, June, July, August, September, and November, once a month, to collect water quality data. And over the summer, it's bi-weekly that the bacteria team goes out to collect data on bacteria. This is a photo from our training, and I'll be leading another training coming up in April and in March for people who are interested to join as water quality volunteers. There is no prerequisite to join the program. You do not need a PhD in water quality monitoring. If you're physically able to go to the river and collect a bottle of water and take some measurements along the edge of the river, that is the only, and you are available for 3 hours on a Sunday morning once a month over the summer. That is the only requirements. And what do they actually measure? The volunteers go out and they measure water quality measurements such as specific conductivity, dissolved oxygen, pH, such as phosphorus, orthophosphate, nitrate, total suspended solids. And the bacteria program measures bacteria such as E. coli, as well as the chlorophyll content of the water. And you can see in red, there are dots showing our main stem sites, as well as orange dots showing the tributary, which flows into the main river, those monitoring sites, as well as in black squares, here are the wastewater treatment plants. And the bright green line shows the part of our river that is designated as wild and scenic. I would also like to add that while that one city in our watershed, which is Billerica, does actually get their drinking water directly from surface water sources, and that the other towns and cities rely on water withdrawals from wells and reservoirs, so many of which come from the watershed itself. So it also is a drinking water source. So to get into some of the data sets that my program collects, so I won't even try to present on all of the data that has been collected since 1994. I'll just show you kind of an overview of some of what has been collected. But if you really want to go in depth, back to 1994 on our website, we have annual reports that show a huge amount of data. I want more people to directly access our data sets. I want people to reach out to me to use these data sets for research projects. I would love to see more people get involved in using these data sets in any way that can help the environment, whether it's conservation agents from towns that want to see these data sets, whether it's teachers in schools who want to use the data to get high school students inspired about local environmental projects. However this data can be used, please reach out to me and let's see how we can help these data sets connect more people to environmental work and water quality. So let's start off with some summer precipitation and flow data going all the way back. So the top graph goes back to 1999 to 2024, and it shows the total summer precipitation for each year. So this is June, July, and August precipitation data. And the bottom graph goes back to 1980, and it shows average summer stream flow for the Assabet and Sudbury. And you can see that this data has variety in the data set going back through the decades, but that it's the past 4 years in particular go like this, because there's a lot of variety in the precipitation and in the flow in the past few years. Here, if we look at the temperature data, you can see that the average temperature, the mean summer air temperature for, this is June, July, and August, has significantly increased from 1999 to 2024. And if we look at the lower Assabet River and we see the water temperature data showed here, you can see that along with air temperatures increasing, there's been a net increase in water temperature as well. And water temperature is an important characteristic for aquatic life because some native species require a certain temperature range. And animals like cold brook trout that are native to the area are only able to survive within a certain temperature range. And the yellow line on this temperature graph is actually a threshold that is defined by the state as a Class B warm water. And you can see that the lower Assabet, that the values on average are getting closer to the warm water type of habitat, which is the change in habitat over time. One important area of measurements for the water quality program is phosphorus. Total phosphorus is the primary indicator that we watch as improvements were made to the wastewater treatment plants on the Assabet. So if you look at these graphs, if you look at the Assabet, what has happened to phosphorus over time? Since the 90s to present, it's gone way down. And this has been one of the major accomplishments that was due to regulating wastewater treatment plants. And the trend analysis shows dramatic reduction in total phosphorus through 2012 when the final treatment plant upgrades were implemented. And since 2012, the main stem concentrations have been close to the target of 0.05 milligrams per liter in all of the main stem sites. And we still have consistently high phosphorus concentrations in some tributaries, such as Hog Brook, that we are watching. This tributary has a large wetland and significant potential developed area runoff, but we keep a close eye on phosphorus in the watershed. Because of those wastewater treatment plants in particular, 4 being on the Assabet, 1 being on the Sudbury, 2 along the Concord River, and 1 along Hog Brook, which is that Sudbury tributary located here. So just to give you a frame of reference of where we are right here at the center of it all, at the confluence of the 3 rivers, also called Egg Rock, where the 3 rivers meet. So there are 8 wastewater treatment plants that release significant volumes of water that they take up water, and once they've treated the water, then they take that treated water and they release it into the 3 rivers. And this shows the average daily discharge flow from those wastewater treatment plants. And I bring up this figure and this number. It shows it by wastewater treatment plant. So the blue line is the Westboro treatment plant, the red line is Billerica, etc. You can see the key. I bring this up because a very large amount of the water that's in our rivers has already been through a wastewater treatment plant. And if I was to cherry pick the most extreme example, which is cherry picked in our 2024 report, at the most severe drought day on September of 2024, 62% of all water flow in the Assabet was from treatment plants. So that monitoring is a large part of OARS programs, both because of our history of being a watchdog for wastewater treatment plants and because so much of the water in the river, when we have those drought conditions, comes from wastewater treatment plants. And you can see it broken down based on plant, the average summer total phosphorus from 2015 to 2024. And along the Assabet River, sites like the Westboro wastewater treatment plant have actually decreased their phosphorus discharge into the Assabet. So that's the brown square portion of the graph that is the Westboro treatment plant, meaning that they are putting less and less phosphorus into the river over time. And that makes a significant impact because that's the largest wastewater treatment plant. During recent years, the Hudson plant has had significant increases in phosphorus into the river because of issues happening with the Hudson wastewater treatment plant. So here, the Assabet River total maximum daily load for phosphorus, which this is data from the EPA, the study was completed in 2004 and confirmed that the majority of nutrients entering the Assabet were coming from wastewater treatment plants that discharged treated effluents into the river. And as the manager, I keep tabs on this EPA data that monitors wastewater treatment plant discharges into the watershed. This is total phosphorus monthly average from Hudson Municipal Wastewater Treatment Plant. And the green line on this graph the dashed line shows the monthly average limit, which is permitted by National Pollutant Discharge Elimination System. So the green dashed line shows the amount that the plant is required by law to keep their monthly average phosphorus discharge into the river below this line. As you can see from the 2023 to 2025 data, this plant has been violating their permit by discharging more phosphorus than what's allowed into the Assabet River, shown by all of the red points. Fortunately, the wastewater treatment plant went through a 24-month upgrade to fix the issues at their facility. And it's just been in these past 2 recorded months that the total phosphorus levels have been in compliance with their limit. So currently this wastewater treatment plant is vulnerable to lawsuits under the Clean Water Act. And I have met with the Department of Public Works in Hudson to discuss this issue with them. And I hope that going forward, everyone at OARS and the environmental community hopes going forward that this upgrade will continue to work and that we will continue to see more green diamonds and not red in our watershed. And this is just one example of how data sets can be used in an application of a real watershed issue happening here in our communities. Another important parameter measured is dissolved oxygen, which continues to show a positive upward trend in the Assabet sites as a result of wastewater treatment plant improvements, especially from the 1999 to 2000 when the wastewater treatment plants implemented limits. So dissolved oxygen is important because of organisms that require oxygen to breathe, especially fish species, and this is their native habitat. So you can see along the lower Assabet, the overall trend is improvements in dissolved oxygen. And another parameter measured is total suspended solids, which measure the non-dissolved particles in the water. And high concentrations of total suspended solids can indicate erosion, runoff, decaying algae, disturbed sediments, or discharge of sediments into the water. And total suspended solids are particles that are suspended in the water. They can make the water cloudy, and in high amounts, they can reduce the amount of light that's available for plants. They can clog fish gills in high amounts, which is something we do not want for our native fish species. And the total suspended solid concentrations are usually highest in the lower Sudbury and Concord Rivers, which is possibly driven by motorized boating, which is common in these sections and can raise the total suspended solids. And our long-term concentration data continue to show an improving trend, which is decreasing in all of the rivers. We also measure chlorophyll A, which is a measure of planktonic algae in the water, and it can be an indicator of eutrophication, which is the excessive plant growth. High nutrient levels could result in algal blooms. Many of you may have heard of blue-green algal blooms, which are a form of algal bloom that not only is it a human health hazard and you're not supposed to go swimming in the water during the blue-green algal bloom, it also is fatal to pets, which is really unfortunate. And it's especially an issue for people's dogs. We measure chlorophyll A in the Sudbury River, and chlorophyll A concentrations tend to increase as you move downstream the river. It's picking up more chlorophyll A, and the concentrations tend to have an inverse correlation with summer rainfall, meaning that when there's low rainfall, there's high chlorophyll A concentrations. And chlorophyll A can also relate to post-flood dynamics, which means that just because there's less chlorophyll A doesn't mean that the eutrophication or the excessive plant growth went away. It may mean that there was a flood and that the system is responding to that flood, such as in the Sudbury River and in Hot Brook in our watershed. Another area of data collection is specific conductivity data, which is highly correlated with chloride, and salt is, if you remember maybe high school chemistry and ACL, chloride is an indicator of road salt pollution, our long-term conductivity data show a clear and significant upward trend in conductivity for all sections of our rivers. It's all going up. And conductivity and chloride data also show that the Westboro wastewater treatment plant is a source of chloride along the Assabet. Conductivity and, oh yes, and I think I change the slide. So this is the data from the Assabet showing a clear increase over time from both salt for roads and wastewater treatment plant activity. I could put this into a figure of how many truckloads of salt are moving along the river. Chloride, we started sampling for chloride in 2018 to measure road salt applications in the river because in New England, the chloride highly correlates with conductivity because road salt is the dominant source of dissolved ions in the region's fresh water. And you can see that I said river water in our watershed flows from south to north. So as the water flows from south to north, it only picks up more salt as it goes along until you get to the end, and you can see how many truckloads of salt have flowed through. Another area of monitoring that I work with in my program is biomass surveying. OARS has been surveying the biomass along 3 impoundments in the Assabet since 2005 to track progress towards reducing nuisance biomass. Okay, so when I say biomass, I'm referring to mostly plants, algae, it can be duckweed, it can be milfoil. Some of you have heard about those familiar friends if you live near a lake like Cotichuet Lake, and many lakes in this area have a milfoil problem because it's an invasive species. And those are the plants like milfoil and duckweed. These are the main plants that we're seeing, and algae as well. These are the main biomass contributors in these 3 impoundments. And when I say impoundment, I'm referring to an area of water that's trapped next to a dam because that's slowing down the water, creating an area of warm water where more plants are growing, increasing eutrophication, especially for plants like duckweed. Trend analysis shows a mixed picture with decreasing trends in some impoundments like the Ben Smith impoundment and an increasing trend in the Hudson impoundment. Hudson is coming up a lot in this presentation. And the analysis of the plant species shows that the Hudson impoundment is dominated by filamentous great algae. And this is what, so this is me and my coworker Heather going out in kayaks to do our biomass survey. This is what the river looks like. And these are examples of the kinds of maps that we create in order to survey the plant and algae and all the biomass in these impoundments by section. And some other invasive aquatic plants include fanwort, curly leaf pondweed, and milfoil. All indications show that the Hudson impoundment is moving towards extreme eutrophication. Sorry to depress you all. It's just data. So all of these, so a variety of water quality parameters go into creating a rolling water quality index, which is used to assess water quality in main stems of the Sudbury, Assabet, and Concord Rivers. Overall index declined over 5 years, meaning water quality is declining, possibly due to the impact of drought and flood cycles, because both droughts and floods have adverse impacts on phosphorus and dissolved oxygen. The upper Assabet index has historically been especially low due to nitrate concentrations, but it is significantly improved as a result of total phosphorus, dissolved oxygen, and nitrate improvements that I discussed. OARS also creates a river report card. I was not working here at the time that the previous report card was created. It rates our watershed as a B for water quality, with some sections as a C rating. In comparison, the Massachusetts Department of Environmental Protection lists all sections of the Assabet and Concord Rivers and most sections of the Sudbury River, as well as many tributaries, on the impaired waters list due to a variety of impairments. I also want to mention OARS bacteria monitoring program. E. coli bacteria is used as an indicator of fecal contamination in water bodies, and Mass DEP has defined a safety threshold value for recreational swimming and boating. E. coli are an indicator of health safety for recreational users. Basically, you don't want to swim in water that has too much poop in it. River Meadow Brook in Lowell and Maynard are both sites where the VAV, which is one of the kind of quantitative measures to assess the E. coli levels, are more than 70% exceeded, which is bad. So you can see that some sites here are in red because you wouldn't want to go swimming there on the day that that bacteria was collected. Some sites are orange and some sites are green. So I'm continuing to design more bacteria studies and bacteria sites, because this is one part of the program where the sites can be changed every 1 or 2 years. The water quality sites, generally, because of the continuity of the data, most of the water quality sites are going to be the same, because we want to be able to compare what happens from year to year, how did the site change. The bacteria ones are one where I am going to change bacteria sites in the coming years, because one of the purposes is to discover bacteria hotspots. We want to know where the bacteria is right now, and then alert towns or work with towns to fix this type of issue. And one example of that is that this year, I have to remind myself, it's 2026. This year, 2026, I'm going to be working with the Department of Public Works in Maynard to address some bacteria leaks or issues going in to the river in Maynard. So I say Department of Public Works. These are the people who run wastewater treatment plants, are administered, municipal plants are administered by Department of Public Works. So these people are not our enemies. In many cases, I would actually like to build a strong relationship with Department of Works. I want to work with towns to help them address bacteria issues, to help them figure out the progress or issues going on with wastewater treatment plants. So it really is a collaborative effort, and working at a nonprofit, I have a certain level of independence and flexibility that I get to form these really cool partnerships where I'm going to go out and do, this one is a detergent survey in River Meadow Brook, because basically my team can go to outflows of water and test that water to see if laundry detergent is present, because if that outflow is not supposed to have laundry detergent, it tells us that some water is going to areas where it shouldn't be. There's a leak somewhere, there's a broken pipe, there's an issue. So it's through a combination of the bacteria testing, the detergent testing, and also DNA surveys that these bacteria tests are conducted. So the DNA test is really interesting because is there a leak in the pipe and sewage is getting into the river, or did a bunch of ducks just come poop here? These are the serious questions I have been tasked with finding out. 2023 data in Maynard showed that there were a lot of geese pooping there. We did geese, beavers, and humans, and the geese were winning that year. But still, there was traces of human contamination. So the real question we were asking was, is sewage getting into this area? and at certain sites of mandated sewage was. And that's an ongoing process of identifying most specifically where the human sewage could be entering where it's not supposed to be. And then in 2024, the data showed that the beavers were beating the geese. And that was interesting to see as well. Some years geese are pooping more, some years beavers. But if we find that there's human contamination, that tells us most of what we need to know. So stay tuned. Who will win next year? So if you want to learn more about water quality and bacteria data, or if you want a really long piece of reading to give to your community college students, to your high school students, if your environmental organization wants to know more, if you work for a town and you want to know about the water quality history in your town, or if you just love water quality, you think it's cool, you want to learn more, you can check out those water quality and bacteria reports. The water quality one going back to 94, currently available on OARS website. And you can stay tuned this year for when I write the 2025 report. And if you want to receive a copy via email personally to you, just let me know. I'll add you to my list. You can sign up for River Otters, which is our newsletter. And that will tell you when it hits. Stay tuned. So our water quality monitoring program is currently expanding. It's expanding so much that I'm going to talk for 5 minutes longer than I thought I was going to talk. And state agencies, municipalities, and nonprofits widely use OARS data to identify impairments in the watershed, plan stormwater infrastructure upgrades, target restoration efforts, and educate the public about what's going on. Now this program is growing faster than ever. I'm going to be working on an environmentally beneficial project due to a source of industrial pollution in Patriot beverages. And I've been told that 70% of my position is allocated towards projects like towards pollution projects like these this year, which have basically this particular site is an industrial pollution site with high phosphorus and heavy metals such as aluminum that were polluted actually coming from a beverage plant. Those beverages were polluting, this industrial site was. And I'm going to be doing a 4-year study along with my amazing volunteer team on Beaver Brook, Mill Pond, Forge Pond, Neshoba Brook, and Assabet River. OARS has historically focused on rivers, and now we're doing lakes. Cool, very cool. OARS will be collecting the data and connecting with the towns of Littleton, Weston, Westford, and Bucksboro, as well as strengthening a partnership with the Neshoba Praying Indians. An indigenous group is going to join our sampling, which is awesome, as well as the Conservation Law Foundation that won the settlement funds to get this project rolling. So thank you to them. And just this past year was the start of a new macroinvertebrate study with 2 sites in Framingham and 1 site in Chelmsford. A macroinvertebrate, this is any animal lacking a backbone large enough to see without a microscope, such as crayfish, snails, leeches, arachnids like spiders, ticks, beetles, odonnates like dragonflies. So if you look at the food chain on your left here, you can see that these macroinvertebrates are at the bottom. And some species are very sensitive to pollution. Some species, I have a chart of pollution sensitivity showing that macroinvertebrates like stoneflies are intolerant to pollution, crayfish are moderately tolerant, and aquatic worms are very tolerant. So me and my coworker and volunteer teams in this photo went out to collect macroinvertebrates at these sites in nets and in buckets. And based on what macroinvertebrate species we find and their numbers, this can actually give us a direct measure of how the pollution impacted the ecosystem. So this is a really exciting new program that can help us quickly determine whether a stream is clean, healthy, or polluted. Does this pique your interest? You want to join? How can you help preserve and protect our 3 rivers? Most direct way, this could be you, is volunteering for water quality, going out to the river. You can come to my training, we'll talk about this more, but you can go to the river and with a bottle attached to the end, picture yourself at the river. There's a bottle here, you're collecting water, you're putting it into coolers, it's going to the lab, and you're able to see from the source all the way, from the source of the water where you collect it all the way to the final graph in the report, the water quality in your community. And if you want to see what our collection instrument looks like, I actually brought one here, so you can ask me to see it after if you want to see the YSI. These are 2 of our volunteers. I took this photo at one of our sites this year. It is very early, so you have to be a morning person. But if you're not, we have other volunteer opportunities that happen at other times of day, such as ecological restoration opportunities. This could be you in the boat going out to collect invasive species, pulling water chestnuts in a canoe or kayak. If you like canoeing or kayaking and you want to do it for free, this is your chance. You can also pull water chestnuts and help the environment while you do that. And we also have Heather, my coworker from Ecological Restoration, along with Division of Ecological Restoration, got it, yep. Along with DER, she runs an aquatic invasive plant identification workshop at public libraries. So if you love going to environmental programs at public libraries to learn cool stuff, such as people in this crowd, you can also go learn about the plant. She'll show you how to tell the difference between Eurasian milfoil and another milfoil that I forget. And this is what some of the water chestnut pulls can bring up. When the algae in plants decay, they generate sewage-like odors, lowering the dissolved oxygen in the water column, impairing aesthetics and use of the river. Aquatic invasive plants are a problem throughout the watershed, and the Sudbury River has this long history of invasive water chestnut, and efforts to remediate this problem have been underway for some years. This is what you could be pulling up, an example. And if you just want to go paddling for fun, we respect it. We also dig that. And we have opportunities for you to become a river rat, a river recreation activity team leader. You could participate or lead a free paddle event to give equitable access to rivers to more people. We also have volunteer opportunities to get involved in facilitating water-wise workshops. So if you are interested to volunteer with kids and inspiring the next generation of river stewards, you can talk to Callie at the table back there. And another fun opportunity to make a direct impact is to participate in a river cleanup shown here, where volunteers pull tires, shoes, bottles, cans, anything you can think of. They found it. They found it all and more. Since 1987, OARS has been doing this. Join us and see what you can find in the river. The water quality program helps provide reliable data to help keep the rivers clean and to support science and public advocacy needed to ensure clean, fishable, swimmable rivers for all. And if you have been tempted into volunteering by my presentation, I have the QR code here. And you can, I already see phones out of people signing up to volunteer for water quality and all the other programs that I mentioned. So I guess if I want to leave you with a few major points in summary, despite the various challenges of pollution that I've mentioned in this presentation, there's been a huge improvement in the water quality in the Assabet River especially, but in the whole watershed, there's been a huge water quality improvement since this monitoring program started. And it's really thanks to the concerned community members who started this organization that this program can continue to run, and to the volunteers who continue to support it, who continue to participate in these programs of monitoring, advocacy, and everything else that we do. And it's these volunteers who really inspire me to do my absolute best to collect the best data sets, to constantly keep working to improve our methods and what we do, and to expand the program in new areas. This is my first year working here, and I'm looking forward to seeing what we can do. So thank you for coming to learn about that. I really appreciate it. I'll take questions. I see you over here.
Hi, I live in the town of Boxborough, and I'm really excited to see that we're on the slide. I work with land conservation, and we don't have any rivers in Boxborough, and the eastern side of the town, like 50% is in the Wasco watershed, and the other side is in the Merrimack. But what we try and do as a land conservation organization, like on all our properties, on our sign, we put what watershed the land is. So we're trying to build literacy, connecting healthy land with healthy water. In 3 words or less, or just tell me to send you an email. We're a headwater community. What can headwater communities do to improve the quality of our water and rivers? And that's probably not a 30-second answer.
Okay, great.
Somewhere.
Okay, thanks for that question. Okay, I would like to get your contact info so that I can send you some PowerPoints.
Okay.
I mean, what you can do to improve water quality, so you're not discharging into the river, so it would be I guess more like land management, wetlands preservation, stormwater management, and creating
not throwing your beer cans into
litter, and also creating rain gardens. But yeah, let me get your contact info,
all right,
and we'll go from there.
Okay.
Cool, thanks. Great. Yeah.
So do you only use data from samples you collect, or do you take data from any other organizations that also do sampling?
Okay, great question. So the question was if me and my program only use data that is collected by the water quality program, or if we use other organizations' data sets and collaborate with them to collect on other data sets. So the answer to that question is that I regularly use US Geological Survey data for the flow of the rivers. USGS has installed gauges that my volunteers read from, and I also use data from the weather station data in my presentation for precipitation was from an airport station that OARS does not run. So normally the precipitation and the flow data are the biggest ones where OARS uses external data sets. And then in terms of collaborating with other organizations, Green Acton is an awesome organization that collects a lot of data. They're especially interested in road salt and chloride. So OARS has in the past also collaborated with them. And that organization has even specifically used OARS equipment to collect their own data sets. So there's kind of a back and forth between different environmental groups. And OARS also has collaborated with the Hop Brook Protection Association. And I would like to expand the collaborations with other watershed organizations as well. So definitely most of what you've seen today, everything besides the precipitation and the flow data, what is OARS data sets, and the National Pollution Discharge Elimination System, the monitoring the wastewater treatment plants, that comes from the EPA. So I use that to monitor the wastewater treatment plants in addition to collecting some more data about it. So yes, we use all the data sets we can, as in addition to, reading materials like U.S. Army Corps of Engineers releases sediment studies and studies on dam removal that our ecological restoration specialist uses a lot. And that program uses a lot of external data sets related to dam removal. Thanks. Yes.
I'm wondering, are you seeing positive results from dam removal?
Am I seeing? So, okay, the person who's best prepared to answer this question is Heather Conkerton, who's our ecological restoration specialist. So I can connect you directly with her. And some of the benefits of the dam removal study include improved water quality. So basically, I'm just going to say yes, especially for fish passage is one of the big reasons why these dams are being removed, is so that native fish species can return to their native habitat. And there are examples of dams where this has happened, so I'm just going to refer you to Heather so that she can tell you all about that. Yes. You have a question?
Yeah, you mentioned cyanobacteria as blue-green algae, right? Do you do any direct monitoring of cyanobacteria per se, or is it just via chlorophyll A, which is contributed?
Yeah, okay, great question. So this question is that I mentioned that monitoring chlorophyll A, and does OARS do more direct cyanobacteria monitoring? That's something that has been brought up at OARS, is if we should expand our program to include cyanobacteria, so that we can better monitor blue-green algal blooms, because there is a state advisory website for these blue-green algal blooms, but some other watershed organizations like Charles River Watershed Association are doing more monitoring efforts within their actual program to monitor it. So it's not something that is being directly measured now. It's definitely something that's come up in discussion as an area where in future years OARS is interested to do more direct monitoring programs, whether it's through traditional water quality river monitoring of actually measuring the on-site data, or if it's something that would be done more through remote data sets like satellite data sets. That's something that we definitely talk about and consider. Yeah, so good question.
Question on about data sets and collection. Do you have any connections with universities or?
Good question. Do we have connections with universities? We have right now tangential connections with universities because a lot of people who volunteer for OARS are retired professors. So we have that kind of connection in a sense of some of them have access to university resources. I am interested to build more direct connections with universities to get more students working with our data sets. So if anyone in this room wants to connect their university to OARS, that's something that we can talk about in the future and what that would actually look like. Yeah, it also has been brought up among OARS staff the possibility of incorporating water quality monitoring into a college or university curriculum so that students could participate as a part of their regular curriculum and kind of enrich our program in sort of like a reciprocal partnership. So that's also a possibility that's been brought up.
University of Lowell, UMass Lowell, I thought that they were into the water quality through their dams, through their canals. Do you know about that?
UMass Lowell was one of the is one of the universities that we've discussed potentially partnering with.
Yeah, they've been doing stuff for a long time. I used to be a regional planner up there
Cool.
half a century ago, and so, you know, I just know that the water studies, and that's the end of the line. So I'm curious to know how good or bad it is, and see sort of trends too. They have data, I just don't know where it is. It's somewhere there.
Yeah. Yeah.
A file somewhere.
There's definitely a lot of data out there that could be centralized as well through a lot of different organizations collecting data. That's a question that's come up among other watershed organizations is like, where can we put all of this data that we have? And the state water quality website is one place where a lot of different organizations do have their community science data sets on the state website, but that's also a topic that we discussed that actually myself, well, I should say OARS, but really it's, when I say water quality program, it's me and my volunteers. I'm going to work with 5 other watershed organizations this year to have a kind of sort of webinar meeting. We're going to have a remote meeting to discuss data management and where to keep data sets. So there is kind of a cross watershed organizational collaboration in that sense, or a coming together of people who want to keep more data sets publicly accessible. I could talk about that a lot more because that's definitely one of my interests coming into OARS as a new staff member is making as many data sets as possible public, accessible, easy for people to use. Well, with that, thank you so much for attending my talk. It was really great.